Good morning, everybody. I am Alex St. John, and for those of you who have never heard of me, many years ago, made your graphics processors and GPUs when I was a kid at Microsoft. See, right here, DirectX 2. That was myself and a couple of friends creating Direct 3D and working with Jensen at NVIDIA and ATI, now AMD, to create the very first GPUs, graphics processing units, for playing video games, and, as we all know now, artificial intelligence. I was hired by Microsoft in 1992 when I was 25 years old to build the Windows 95 and NT streaming print architecture. And I moved on from there to build streaming gaming and the streaming video formats. So the early DirectX team created all your streaming video, which is Direct Show and Direct Video and Windows Media Foundation. We created all of that for your video conferencing, your audio conferencing on Windows, your multiplayer gaming. We built the 3D technology for the DirectX box, so the operating system that enables all graphics and gaming and media and 3D and sound and multiplayer networking to synchronize and work on Windows. We built all of that when we were kids. And after that, I founded Wild Tangent. We built streaming mapping, sold that to Google. So I'm the creator of Google Maps, ironically. Wild Tangent pioneered streaming game publishing. We made the first app stores. And then after I left the gaming field, I went into scientific computing because the GPUs that we designed in our youth became the most powerful movie rendering chips and scientific computing chips. And a lot of people in academia started wanting to build GPU supercomputers and needing people like me with the expertise to design the supercomputers. So I then went and built streaming radio astronomy telescope supercomputers, streaming fusion technology for containing plasma at 10,000 frames a second, fusion plasma, streaming genomics platforms. I worked with Weta on helping them optimize the streaming graphics pipeline for CGI movie rendering, and they had Weta at one time had the people who made Lord of the Rings, Peter Jackson Studios, had one of the largest GPU supercomputers in the world. They might still have that size. So everybody had the same problem with GPUs as they went into mainstream use for scientific computing. You couldn't get the data through the GPUs fast enough. They were I/O bound. And almost 20 years later, it's an artificial intelligence revolution, and everybody has the same problem now. And I'm an expert at solving it. And so I can't sit on the sidelines having the singularity happen out there and not help out, because it drives me crazy. Watching everybody struggling to run artificial intelligence on normal computers at home. And today is a really exciting day because Moonshot AI is releasing Kimi K3, the largest frontier model ever released to the public. It's 1.4 terabytes, and it just dropped this morning, 41 minutes ago. All my computers and the office computers are downloading fragments of it in the background. We're trying to get it in here as fast as possible. And supposedly it's better at programming than Claude and OpenAI and any of the massive commercial grade platforms. So it's an amazingly powerful AI. And everybody wants to play with it. Everybody wants to use it. Everybody loved the idea of not having to spend the thousands of dollars on cursor tokens I just spent to create the Sylon platform I'm about to announce. So everybody liked to be able to have access to that kind of artificial intelligence. And the problem is the way artificial intelligence is built, it requires giant supercomputers. Kimi K3 says they need 64, giant data center grade NVIDIA GPUs to just run the damn thing. And I don't have that. You don't have that. We want to play with the model, and we can't. So, as the father of Windows gaming and streaming technology, I'm here to announce Sylon. And it's an open source project to make a standard streaming format for artificial intelligence. So just like we figured out how to stream music, and just how we figured out how to stream games and stream video, I'm going to show you how we're going to stream artificial intelligence, and I'm going to run an open source project to enable it. And we're going to solve all kinds of really fun computer science problems that the industry is really struggling with. And I hope that by doing this, I'm going to get artificial intelligence into everybody's hands. Everybody wants a piece of the singularity. I don't want to be paying these massive bills. I want to run the world's biggest, smartest AI supercomputer at programming on my home laptops, so I don't have to pay Cursor or any more than I want to. So how's that work? Everybody's going to tell you, I'm surprised. I've been building this kind of technologies for decades. I've had my hands arm deep in GPUs for my entire career, and I never thought I'd see a day where you had an artificial intelligence revolution going on in a toy academic programming language like Python. And so causing this shocking bottleneck and appalling architecture that causes artificial intelligence to be so hard to use. So we're going to unpack that here, and I'm going to overview what the Sylon project's going to do, what it's going to contain very briefly, and then in subsequent episodes we'll go through it in more detail. So the base concept is we're going to stream artificial intelligence. What's that mean? Well, I got a prop here. This cable is 1.4 terabytes of Kimi K3. It's got something like 70 layers, 860 some experts. It's massive. My head is the GPU, and it doesn't fit. I can't think about this thing all at once. I just don't have a big enough brain. So what we're going to do is we're going to stream Kimi K3 through my brain. We're just going to feed a token in this end, and we're going to pull it through one layer at a time on my 24 gigabyte laptop until out pops a result. And then we're going to feed it back to the front again, and then we're going to pull it through the GPU one more time. And we're just going to keep doing that until we are running the world's largest frontier models on toy consumer hardware slowly, but we're doing it. And it's not going to require thousands of dollars clusters. You're not going to have to shell out for rare NVRAM. I'm going to show you how we're going to make streaming artificial intelligence totally practical and a normal everyday thing, just like we did with streaming music and video and games and maps and printing when I was a kid. So how are we going to go about it? How are we going to solve that problem? Well, so step one, the entire Python ecosystem of artificial intelligence is vendor bound to the CUDA language. And some of us have NVIDIA laptops because we're huge nerds, but most people don't. Most people who are gamers have AMD GPUs or Intel GPUs. And wouldn't it be nice if you could run those models across all of them? So the very first thing we did here on the Psilon project is we took PyTorch and the CUDA backend, and we're replacing it with a Vulkan, a DirectX 12, and a web GPU backend, all optimized to run on anybody's computer. So, and we're going to open source that so that right out of the gate, you can conceptually, any computer, whether it's got tensor cores or not, doesn't matter. It's going to be able to run artificial intelligence. It's going to be able to run the model. Maybe slowly, it's going to be able to run it. Or not at all, because you don't have enough VRAM. And then I'm going to introduce PsyCache, and I've got a separate episode for that. And PsyCache plugs in under PyTorch and makes AI streamable. It takes any arbitrary AI model and outputs it in a form that can stream through a GPU like I just demonstrated. So it doesn't matter how old and crappy your computer is, you'll be able to run a frontier AI model at some scale on it. And that's how streaming begins. You go, well, why do I want that? It's going to be slow. Not for long. You just have to get the chain. You got to get the chain reaction going. You got to get everybody to realize that they don't have to compute AI the way they have. There's a way out. And once you get everybody excited about streaming, suddenly it's real time. And I'm going to even show you the path for getting there. So here we're going to do several things. First, we're going to replace the entire PyTorch and Python AI ecosystem that is vendor locked with Vulkan. Because Vulkan runs everywhere, Windows and Linux, and maybe Mac, I don't know, I'm not a Mac guy anymore. I'm releasing this SDK in Windows. Feel free to spend your tokens to help me port it to the other platforms. Coming soon. I'm just going to focus on Windows because that's where all the gaming GPUs are. And the gaming GPUs are perfectly good AI chips. They have all the same capabilities, and they can run AI models really well if you just make that entire tool chain mess go away. So step one, we're going to open source Vulkan backend to PyTorch. I know they exist, but they're meant, the ones that exist are really meant for industrial scale uses. This is not ROCm. This is going to run on your gaming GPUs and everything else. So this is meant to be a the most broad, or horizontally integrated solution for running an AI platform that you possibly can get. And I'm going to be fusing more, generating more and more Vulkan libraries that we're going to work our way down through the entire CUDA ecosystem until AI models and that, and every architecture and part of the ecosystem that's relevant when I'm done is going to work on anything, work on any decent gaming machine. 2, streaming. So PySciCache is going to stream AI models, arbitrary, just not modifying. We're not going to just anything on Hugging Face, throw it up there, Hugging Face, whatever, throw it up there, and we're just going to automatically make it streamable. So at some speed, we're going to pull it through your GPU. It's going to work. It's going to spit out tokens. 2, 3, adaptive quantization. So the entire what we're going to do today, as fast as Kimi K3 downloads here, and I'm going to post this video before Kimi K3 is done downloading. So it's 9:49. I got a couple hours left. Because the reason I want to post this video is I'm going to run Kimi K3 on this laptop. I don't know if it's going to work. I've never had it. I've never run a model this big. It's the first time I've had a model I could even test with Sylon this big. But I think it's going to work. And that's the point. So I'm going to commit myself to running Kimi K3. Then I'll do whatever I have to get it working. I've been up for 2 days straight so far already, so I'm pretty jacked on. I've had a lot of coffee. We're going to run Kimi K3 for you, and I'm going to show you the results. So it's not going to be blazing, but I bet you it works. And then 2, we're going to open source the PyTorch libraries for Vulkan. Then I'm going to open source the Hugging Face top-level libraries on top of Vulkan as well. Then we're going to fuse all of those AI libraries in Vulkan so they run faster than they do on CUDA, on the same NVIDIA chips. So the interesting thing is, it's not that CUDA couldn't do this, it's just that nobody does, or only Anthropic and OpenAI have the computer science people who have done this work in the labs for the big models, but out in the consumer space, you don't really see that done at scale. We're just going to make that happen. So we're going to start fusing and batching Vulkan calls, so that not only does your AI run on your old broken down GPUs, runs well, runs better, faster. So we're going to speed it up by doing that. 2, get the streaming architecture, caching working. We're also going to be able to do distributed computing, distributed AI. So caching, streaming is being able to pull a giant model through a smaller GPU. Caching, these new generation models are mini experts, and each of those experts needs to be cached and pulled into the GPU on demand. So PsyCache does that. And then there's a thing called tensor parallelism, where you take the layers. So right now we're going to pull one layer through at a time to process it through a limited GPU. But if you have a really old crappy GPU, even that's not going to be good enough. So what we're going to do is take the layers, slice them up, which is called tensor parallelism. We're going to put them through in series. And ironically, doing that will speed up all artificial intelligence, including on the giant supercomputers. So everything we're going to do to run artificial intelligence on your crappy 5-year-old laptop is going to make AI actually work better in the data center, ironically. It's better architecture. It's just the academics with Python aren't super, or the Anthropic and OpenAI have hired all the people who know how to do this. They can't formulate AI in an efficient way to compute it, but we're going to change that here with Sylon. So then we're going to do batching, fusing, streaming, caching, distributed, all of those things. I've got it all generated out here. We're going to release them one at a time. We're going to get benchmarks, and we're going to create a Sylon format, just like MP3, MP4. I don't know if .mp5 is trademarked, so I'm going to call it a .psi format, and it's going to be able to contain any AI model at full quality without any manual fiddling around. And you're not going to need to do any, I got to jank some Linux boxes together and network them and manually quantize them to try to fit and hope my model didn't get too dumb to use. You're not going to do any of that. You're going to run models at full quality. Where we are going to quantize models, just like when we make a streaming media format for video or for music, we're not where we quantize, you're not going to notice it, because we're going to do a smart adaptive quantization to the stream. Because when we've changed a compute-bound problem like artificial intelligence today to a streaming I/O-bound problem, we actually free up a bunch of GPU cycles we can use to do smart stuff, like adaptively quantize any model in a way that doesn't make it dumber and makes it smaller and faster. So you just magic when you stream things. So we're going to do all of that. It's going to be in the Sylon project. I'll be doing episodes on a regular basis as I talk about how these ideas and how we get them into the public domain. And I hope you'll all join me on the trip. Come and again, it's just me, so I don't have a lot of help, but come on up, comment, give me some support, donate some tokens and some IQ processing. Help me get it ported to Linux and Mac, if you will. Help me review all the AI-generated vibe code, because I'm shamelessly going to vibe code this thing. And my first hope is you're going to see me right after I do this video, download Kimi K3, run it on my laptop, and then from then on, I hope I don't have a massive Claude bill like I had to generate all of this, because I'm going to be running Kimi K3 to do my workloads, which I know is going to take a minute to really be efficient, but I've done this before. We're going to get it done. We're going to be able to stream artificial intelligence in the world in which you have giant Arizona data centers with clusters of huge dedicated hardware and infinite RAM prices is going to go away, because that's silly. So it was a dumb way to do this. We're going to fix all of that. So thank you for joining me. I'm excited to announce Sylon. Go and pin the page. I've got down the bottom of the page is a website, my YouTube channel, Discord channel we set up for people to comment on. And stay tuned, because hopefully in a few hours, you're going to see Kimi K3 running on my laptop. Wish me luck. All right. You guys all have a great day, and I'll see you. See, I'm committed now. I'm posting this. You're hopefully going to see me in a few hours. Sight unseen. I'm going to run Kimi K3 through Sylon. That's how freaking confident I am. Knock on wood. All right, take care. I'll see you in a few hours. Bye.